Um, Today, I'm pleased to introduce two speakers from MLC, Corey Mueller and Michaela Hall. Today's webinar will be focused on calcium hydroxide products and delivery systems for fermentation, product selection, precision dosing, and expert support for scale-up. MLC is a current Biomade member, and I hope many of you had the chance to meet them at this year's Biomade member meeting. To introduce our speakers today, Corey Mueller is currently the Technical Services and Application Manager at MLC. Corey is responsible for working with customers on the selection, material handling, application, and performance of calcium products in a range of industries, including water treatment, specialty chemical preparation, food applications, and fermentation. Corey is also heavily involved in R&D, developing new products and applications for calcium carbonate, calcium hydroxide, and calcium oxide-based materials. Prior to joining MLC, Corey earned his BS in chemistry from Southeast Missouri State University, followed by a PhD in chemistry from the University of Texas at Austin. I'm also pleased to introduce Michaela Hall, who serves as Director of Market Growth as MLC, leading business development efforts that span new product launches and the company's expansion into emerging markets, such as fermentation for bioindustrial manufacturing. She brings a technical foundation to the role, holding a BS in chemistry from the University of Nevada, Las Vegas, and an MS in chemistry from the University of Oregon. Corey and Michaela, thank you so much for leading today's webinar, and I'll pass it to you.
All right, thank you very much. And I just want to say thank you to the entire Biomade team for putting together this webinar and welcoming MLC into the Biomade community. We had the opportunity to go to that members meeting that Laura mentioned just a minute ago, and it was a great show. We got to meet a lot of good people there, so we appreciate everything that you all have done on your end. And I also want to just say thank you to the attendees on the call for taking the time out of your day to listen to our talk and learn little bit about calcium hydroxide products and their delivery systems for fermentation applications. So we got a lot that we want to go through on the talk today. So just to kind of give you a brief overview of what we're going to be talking about, where this is all going. We're obviously a calcium hydroxide, calcium oxide manufacturing company. And so the use of these materials is commonly associated with pH control. And I don't think I need to tell the people on this call how important pH is to the efficiency, the health of the microorganisms, the overall process within the bioindustrial applications. And so we want to talk about lime calcium hydroxide and its use within these systems and talk about some of the perceptions and the performance of calcium hydroxide that may persist within the industry. We also want to talk about, the total cost of alkalinity. There are several reagents that are available for controlling the pH and raising that pH. And so how does calcium hydroxide compare versus all the other alkaline reagents out there? Not just in the cost of the reagent itself, but also in all the total costs surrounding it, material handling, safety considerations, equipment considerations, all the different things that can play into that total cost of production and manufacturing. And then we'll kind of switch to some of the solutions that our MLC has that can be made available that can help you through the pilot scale to lab scale to pilot scale all the way up to full production scale. So things like our portfolio of products, expert services, and helping you figure out what products are right for you and how to best use these materials. And then even the CalFlow system, which is really a unique system that can really eliminate a lot of the challenges of dosing and using calcium hydroxide products and really help kind of give you that best performance you can get. So before we get into the details of all of this, I do want to take a step back and kind of introduce us because MLC, we are new to the Biomade community, so we want to make sure everybody's aware of who we are and what it is we do. So MLC, we are a world-class supplier of calcium-based products, predominantly calcium oxide, calcium hydroxide, and calcium carbonate materials. We've been manufacturing these materials for well over 100 years. We work very closely with our customers, trying to make sure that we have products and solutions that match their specific needs, as opposed to the one-size-fits-all solutions that can exist. An exciting development for MLC is the joining of Burnett with the MLC team. Burnett has spent their time really looking into the liquid calcium hydroxide handling, dosing, delivery systems, and they've really perfected how these systems work and have put together a really good solution that makes this essentially a very low touch, low mess, high precision based system that's great for a variety of applications, including those within the fermentation space. So we really think that the combination of MLC and Burnett lime, it provides a really good solution. So lime, just kind of want to introduce this term, make sure that everybody is here on a level playing field because some never want to assume that everybody's been familiar with our products before. Lime is kind of a catch-all term that's used within our industry. Uh, It's really covers a wide variety of calcium-based products. And so for this talk, I'm going to do my best to refer to the products as name, calcium oxide, calcium hydroxide, etc. But you're probably going to catch me slipping a few times because the vernacular is just so predominant within our industry. But when we're talking about lime, we're talking about these three major chemicals, all of which we produce. So you have calcium carbonate, which is the limestone. That's the kind of the feedstock to all these other products, as well as the sold material. That material can be calcined to form calcium oxide, or otherwise known more commonly as quicklime, and it can be reacted even further with water to generate the calcium hydroxide or hydrated lime product, as it's commonly called. So we'll go into a little bit more detail here on how these products are actually made, just to give you kind of a sense for how it does. I know a lot of people on this call are technical in nature, and so we all love to hear how things are made. So calcium oxide, its production process, as we mentioned before, starts with calcium carbonate. The calcium carbonate is mined out of our deposit. It's crushed and sized to the appropriate size, and then it is fed to something called a kiln. These kilns heat the limestone up to incredibly high temperatures, over 1,000 degrees Celsius. And under those conditions, the calcium carbonate breaks down into calcium oxide, giving you the quicklime calcium oxide product. That material can be screened and sized to a variety of states to provide it to different industries, all the way from, big 2-inch based materials all the way down to extremely fine micron top-sized powders. So these are sold to a wide variety of industries, but they can also be carried over further into the calcium hydroxide production process, which is shown here. So in that case, the calcium oxide is fed to something called a hydrator, which is pretty much exactly like it sounds. You take the calcium oxide and you add water to hydrate the material. The calcium oxide and the water react to form calcium hydroxide, and it releases a whole bunch of heat. That as that material goes through this system, it eventually discharges the hydrator as a dried powder using the heat of the reaction itself to dry the material, which is really a pretty cool processing stage. From there on, the material can be further refined depending on the grades, needs, requirements of the particular industry to generate the finished calcium hydroxide powder. And that is provided to our customers either in a dry state or it can be mixed with water to form a liquid calcium hydroxide slurry. And that slurry can be delivered in bulk tank and handled from there as another means of receiving this material. So we do this in our geographical footprint is pretty heavily centered within the Midwest to the east. We have several production facilities spread across that range, as well as distribution terminals and points. And this gives us a lot of touch points to be able to provide our products to our customer base, including options, bulk packaged, 50-pound bags, super sacks. These can be delivered via truck. We also have options by rail and even barge to move these materials around the US and make sure that we have close touch points to all of our customers utilizing these materials. And it's a good thing too, because really lime is used all over the place. And this is kind of a for your information type of slide, but lime is used all sorts of industries and it really touches your lives in ways you probably never would imagine. So, things like lime can be used in things like construction, purifying steel. It can be applied to soils to stabilize the foundation which you build on, put into asphalt to actually help the material bind with the aggregate and give you a more stable asphalt base, as well as other adhesive sealants and building materials. So you can have applications such as that, but then you can go all the way up to grades that are suitable for things like chemical manufacturing. So refinement of metals, preparation of rubbers and plastics, where it's used as a desiccant to scavenge water. It's a main ingredient in glass, paper, production of different calcium-based salts that can be used in food and other applications. And food is a really kind of an interesting one. The same material that can be used for all these other things, it can be used to actually for food grade applications. A big one of these being the use of lime in nixtamalization processes. So your corn tortillas, corn chips, things like that. Calcium hydroxide actually plays a key role within this processing to make those foods. So at some point in your life, you've probably eaten calcium hydroxide prepared materials. And within this subset too, you have people within the fermentation space who use this material to help control their pH for various applications. Another one kind of interest is water. People use this not only to treat industrial wastewater or municipal wastewater, but it's actually used to treat potable drinking water to soften the water, adjust the pH, and make sure that it's clean and healthy, not only for the distribution systems, but for the consumers and use. So there is a wide variety of uses of calcium-based products within the industries. And so it's kind of fun to show this to people to help everybody realize how widely this product is used.
So Corey talked about, the chemistry of calcium products, where we make them and the various applications where it's used. And really I'm here to kind of give a little bit of insights into how the fermentation actually uses calcium products in the process. And so last year, we actually used a third-party company, and they went out and surveyed the industry and talked to 60 different organizations. And so here's kind of what they told us. And so one of the first questions we had is kind of what are the end products and how commonly are calcium products used in the production of products via fermentation? And so what you see on the x-axis here are the various end products that those surveyed produced. And what you can see in the light blue color are the people who said, yes, they use calcium products in their production. And so what you can see is really there isn't a category here or end product here where lime or calcium products are not used. What you'll see is organic acids, ethanol, and animal feed supplements. I would say proportionally have a higher use of lime compared to not use. But even the big industries like food and bev and pharmaceutical definitely have exposure and utilize calcium products in their production processes. And so we wanted to take a step further and say, let's take a look and see what alkaline reagents are used across the industry. So taking that step down. And so what we can see here is that the number one alkaline reagent used is really sodium hydroxide, followed quickly by calcium hydroxide. And you can see that the other calcium products are also commonly used across the industry. And so really, when you add all of those calcium products together, that really is, the most commonly used alkaline reagent in the industry are, the various forms of calcium as an alkaline reagent in their process. And so now we saw, what products are used or what alkaline reagents are used. We wanted to really understand, so what is the function in the process? And so I'll kind of walk you through what we have here. So on the left-hand side, we have overall. So all of the people surveyed, understanding how do you use alkaline reagents and what's the function. And so 70% of those people said this is for pH adjustment. And what you can see in the light blue bar are those people who used it for pH adjustment and product isolation. What you see next is product isolation only. And then 5 of the 60 respondents or 5 respondents said they don't use it or any alkaline reagents at all. So you can see pH adjustment overall is the biggest use. And when we talk about calcium products specifically, that ratio shifts a little bit. So it's about 50% use it for pH adjustment alone, whereas the rest of the sample size really use it for product isolation and pH adjustment. So showing kind of a little bit of a different function here for calcium products compared to what we see over here for all of the others, where it's heavily skewed. 80% is really being used for pH adjustment on its own, with a much smaller share being used for product isolation. So you can see here, where it can have some uses. In addition, I think it's worth mentioning that, calcium products are often used to treat processed water, and wastewater as well. And so we kind of understand, where they're used, how they're used. And so our next question was really around, do you have any challenges in using alkaline reagents? And so it was about 50-50, whether people had concerns or not. And when we talked about the other alkaline reagents, the biggest concern, almost 50% of the people had issues with product consistency, as well as material handling and regulatory concerns. And so then we asked people who weren't using lime, was there a reason why they didn't use calcium products? And, we'll talk about a lot of these today, but the number one answer was difficult to use, purity, process constraints, and cost. But I think one of the big takeaways is regardless of what reagent is used, material handling and product consistency are some of the largest concerns. And so this is, the last slide that we'll have on the specific results, but I think it segues into really how we can help this industry. We also asked those utilizing calcium products, what were their biggest concerns in using it in fermentation? And so, there was equal number of respondents that said no concerns at all, as well as challenges with handling. Followed by concerns with safety, concerns with quality, regulatory, and product consistency. So you'll see some overlap kind of in the industry in general, but now we'll talk a little bit about how, what we have to offer can really address several of these concerns.
So as we mentioned before, pH control is critical to fermentation, bioindustrial applications. It's fundamental to that microbe health, productivity, yield, product purification, all the various stages that you have to go through to actually get a usable product out of your process. pH control plays a critical role in that and all the downstream steps. Calcium hydroxide in these products, as Michaela showed in her survey, it's already widely used within the industry. So people know it works. And, as in all cases, there are certain times when chemistry is exclusive to particular options, but oftentimes the challenge is not necessarily the chemistry for these people. It's actually in the execution of being able to successfully apply the material and go through that. So that kind of leads us into some of these major challenges that, Michaela had talked about on the prior slide. And a lot of these kind of add to that perception of why it can be difficult to use calcium hydroxide in some of these processes. So of these concerns, these are kind of 5 major themes that came out of the use. So one being the potential for local pH shocks. Whenever you add that reagent to adjust the pH into the batch, you're going from a higher concentration state to a lower concentration. And so that by necessity means that you have that opportunity for high localized pHs. And so trying to avoid that and making sure you don't get that kind of stress on your system is very important. And this is one of those challenges that I don't think is necessarily exclusive to calcium-based materials. This is true whether you're using a concentrated solution of any other alkaline reagent. But there are ways to kind of help and address that type of challenge that we'll talk about here in a while. GMP is another major concern, the cleanliness of the products. A lot of these systems you don't want to you want to have good control of your environment. A lot of times for calcium hydroxide, traditionally it's delivered as a dry product and it's a powder. So that always gives you the opportunity for dusting and material handling challenges. With a well-designed system, you can really mitigate a lot of those challenges with the dry product. But if you're really concerned, taking the liquid calcium hydroxide eliminates a lot of the dusting and control challenges that come with handling powders. And that can be a very good thing for your GMP type of environments. So that's something else that can be used to help address some of these things. Scale up complexity, of course, is a major challenge, especially in those startup developing companies. Going from lab scale to pilot scale to plant scale it's not a trivial task. I think I don't have to tell this group that, when you go from 1 liter to 10,000 liter, things don't scale linearly. You have mass flow considerations, heat flow considerations, mixing dynamics. There's a whole bunch of things that are going to change. So having systems that can be used the same at both the low and the high end, you're always going to have to fight those dynamics that come with scale up and the changes that come with that. But knowing that you have the type of system that at least can eliminate some variables going into that process is a very important thing to de-risk your technologies. If you are a process that needs food grade compliance, that's obviously going to be high in your mind. And so having supply from a supplier that gives you that food grade compliance, being able to give you the documentation you need, being able to guarantee to meet the FCC and chemical codex specs, and having the GMP certification processes around the products can give you a lot of ease of mind whenever you're talking about particular processes that have this as one of their main sensitivities. And then finally, true cost of use. I think anybody who's here trying to develop these processes ultimately wants to make some money off of it. So obviously, the cost of using the reagents comes into play. So, when you're thinking about this, you're not only thinking about the usage of your reagent itself and how much it costs per ton of material, per pound of material, but you also want to be thinking about all the other ancillary things it touches around the reagent that you're using. And so these are all things here we'll be talking about in the coming slides. So, within fermentation reactions, we know that there's a wide variety of choices of alkaline reagents that you can use. We wanted to kind of throw up this nice comparison to give you some idea of the different properties of these materials. And these are just not comprehensive, but it kind of puts us against some of the common materials that are used for these style of applications. So, we were just talking about price, so that's a good place to start. When you're looking at the reagent cost, obviously that's going to come into play when you're thinking about taking this to the production scale. Well, the economics make sense. So you want to think about not only your reagent cost, but also the neutralization capacity of that reagent, because how much you're going to have to use multiplied by the cost, that's really going to give you more of what you need in terms from a raw reagent use standpoint, how much you're going to need. So having something that has a good neutralization capacity, it takes less material per pound to neutralize whatever acid you're producing. That's important, as well as the price point of that material. So you can see that there is a range there for you to consider whenever you're looking at the reagent choices. The pH range of the reagent is also something that's important. Obviously, you're going to need something that is capable of reading your pH and making sure you're staying within a good working range. But at the same time, most of these fermentation style reactions, you're not working at extreme pHs. So having some limitation to how high you can spike the pH or move it does come into play. So being able to, you can have to balance the working power of the pH of that reagent, as well as some limitations in terms of the max pH can give you some extra control and protection against how you're dosing and running your systems. After you've dosed these reagents into the system and they've reacted, you got to start thinking about eventually you're going to have to clean this process up and get your end product out. And so understanding what the byproduct tendencies will come into play. Are you running a type of process to where you're going to want to separate out a lot of the solid bulk material to where you prefer something like a nice heavy precipitate that can easily be centrifuged or filtered out? That may be what you're desired. Or if you need something that's soluble, then you might push you a different way. Then you have things like ammonium hydroxide, which can give you kind of some unique properties with that ammonia being able to be a nitrogen feed source within your actual fermentation reaction, if that's something that you need to think about for your particular reagent. Looking at what happens after you react with the acidic species to adjust that pH a little bit higher is important. And so things like the byproduct tendencies, the total dissolved solids, how much of that material is going to be left in solution versus the tendency of it to be a solid precipitate, that will come into play when you're thinking about your purification streams down line, as well as the properties of the ions that byproduct is contributing. So things like calcium and magnesium, they tend to be lower solubles, form those precipitates that can have benefits. Also, things like calcium tend to, being a divalent ion, it tends to be a little more sticky. So that can improve some separation efficiencies when you're thinking about exchange resins. However, if you're wanting something where you need to keep it solubilized further, you have things like sodium, although you have to worry about how much of that sodium is ultimately going to build up within the broth and concerns how that affects the health of the microorganisms themselves. So there's lots to think about in terms of the byproducts of the reaction. And then finally, it may not be the most exciting side of things, but just material handling considerations come into play. And really, that's where something like the CalFlow system, which we've mentioned a few times, and I promise we'll get into details on more of what that is here in a few slides. But having a known dosing system that really takes away the pain points and the control points that you normally have to look at and can give you that nice, reliable system lets you focus your energy on other things. So when you're thinking about handling considerations, having a nice, easy to move material is important. Things like caustic, and ammonium hydroxide, they tend to come fully in solution. They're easy to pump and move around. Now, you'll have some things to consider, such as safety, corrosivity, or any sort of potential vapors in the case of ammonium and the odors. But at the same time, it is easy to use. So you have to balance all the pros and cons whenever you're trying to make these selection choices for your applications. And so this table here, it's a lot of data, but it kind of shows you when you're trying to think through this profile and what works for you, some of the things to consider. So what can MLC, how can we help you in your processes in terms of making sure you're successful from lab scale to production scale? Well, we kind of broke this down into three major categories. One is we have a broad portfolio of products that allows you to pick what's right for you. Second, we have expert services that we can provide to kind of help assist you and work with you in these processes. That can go from helping with that product selection from the portfolio of products that are there, as well as recommendations in terms of how to better design your systems to move our material, as well as kind of technical application support. And then finally, you have something like the CalFlow system, which really gives you this convenient platform to be able to run this pH adjustment system off of. So let's start with the portfolio of products. As I mentioned, having some selection is very important versus trying to fit into a one-size-fits-all type of solution. Being able to select a product that has the right reactivity, particle size, GMP, and certification compliance for you and your needs becomes very important for being able to pick the right product for you. And so there are several grades that MLC does offer, just depending on your needs. For some applications, if all you need is pretty coarse base pH adjustment, you know, depending on how much performance you need out of the product, industrial grade may be fine for you. And then we have the GMPs, ISO 9001, it'll cover systems like that. So you're getting a good quality, consistent process. However, if you're kind of in the ballpark where you need higher performance, higher consistency, more specific reactivities, something like the chemical grade series and the microcal series or the VitaCal food grade series can give you tighter control of things like this to where we can tune the reactivity of the material to whatever is ideal for your specific needs. This comes with particle size control, top size control, morphology control. There are options there to where you don't have to adjust your process around one type of product. You can see which type will give you the most flexibility within your process to run. And then, of course, if you need that food grade certification, there is the VitaCal line of products. This gives you the GMT certified systems of the FSSC 22000 to make sure you have those quality control systems in place for making sure you're getting exactly what you need, the documentation, FDA registered facility, all those types of things that are very important for you to be able to make the food grade products. So, it's easy to say all this, and I wanted to make sure that we showed some of this control that we're talking about here in terms of these products. And really, one of the things you learn when you're first going through school and going through chemistry is that structure helps determine properties. Now, to be fair, when most people say that, they're talking at the molecular level, not the crystal size morphology. But I think in this case, because we're talking about solid particles and liquid interactions, this easily applies to the calcium-based processes, to where controlling that particle size, controlling that surface morphology will help control those kinetics, the reaction rates, the physical properties of the calcium hydroxide solutions. And so what we show here are some SEM micrographs showing different types of particle size and morphologies for our calcium oxide and calcium hydroxide products, showing different controls. as well as a variety of particle size distributions for our hydrated lime materials, calcium hydroxide, that can be used to govern how the material handles and performs within your process. And so having that selection is a very important step in terms of getting the right material for you. So expert service, that was the second solution that was available through the MLC platform. And one of it comes with, we showed you a bunch of different options on the prior slides, helping you pick out which one of those would be right for you and understanding all the different intricacies of the material. We're more than happy to work with our customers on understanding what those are and what they do for them and what might be of most interest to a particular process or application. So we can help with that product selection. There also is engineering and consultation. So once you have an idea which product you want, in terms of developing those lime handling systems, how do you pump it? How do you mix it? How do you dose it? What I'll say is engineering firms, I mean, they are great at what they do. They know how to design systems and materials, but just like any sort of chemical or any other specific, the devil's in the details, and each chemical kind of has its own unique characteristics. And so us as calcium manufacturers, we understand what those are for our products, and we can help review engineering firms' designs, make sure that they're catching the nuances. That way you get that easy to operate, clean flowing systems. And then as you think about going to scale up, working from your system from pilot scale up to production scale, to de-risk your technologies and to make sure that it performs the way that you need it to and help you kind of dial things in. We do offer temporary equipment solutions through our equipment solutions program. These give you units that you can actually use on large scales to try out the material before you commit to that final purchase, to help you kind of figure out exactly what it is you need and de-risk the system. So there are rental options and that can go along with that. So we like to work with customers and help support on that side of things. And then finally, even whenever you go past, once you settle on your product, settle on your system and taking material, we like to stay in touch with our customers, make sure we're working with them, help them troubleshoot anything that might come up or give them tips. We're happy to provide that ongoing technical support past the point of purchase.
Mute myself. So we were at the BioMade conference and a lot of people kind of came up and were like, what is CalFlow? So I wanted to kind of start this section off to really talk about what CalFlow is. And I would say it's two things. It is a system. It also is a product. So we also have CalFlow slurry product, but today we're going to talk about the system specifically. And so this is something that really is a closed loop delivery system. And so you can see here a picture of what it actually is. And it is a tank with a mixer on top that keeps the slurry stable and consistent, just regardless of the level. And kind of within this housing houses some redundant pumps to make sure that there's backwashing and uninterrupted flow, as well as a PLC control system that really can kind of loop into whatever control system that you have on site. And so really kind of, what does that matter, or kind of what does the industry, how can this provide value here, is really around clean, precise, and bolt-on. And so, anyone who has any exposure in utilizing calcium products at an industrial scale can understand how it can be really a challenge on the handling and the dusting. And so this really is a no mess, closed loop system that, as Corey mentioned earlier, is really compatible with GMP type applications. Precision dosing is really one of the things that is where CalFlow really shines, and really being able to precisely control how much is going in, and again, kind of addressing or mitigating the challenges with pH shocks. It is a stable and consistent slurry. So all the way, despite the level in the tank, it really is going to be the same concentration, regardless of where it's at. And will be delivered all the way, from delivery to use. You can guarantee that it'll be, a reduced grit slurry and consistent for use. And then kind of once we're talking about, actual installation and investment, there's definitely some options. They've really mastered the installation to where that really is a one-day install. So when you're talking about kind of de-risking your manufacturing and kind of scaling up, that really is something that doesn't have a lot of impact on your construction timeline, as well as kind of some, flexible investment options when we're talking about, CapEx. We can look at some leasing options and things like that. And so it's really simple by design and precise where it matters. And so here, kind of in summary, really, highlighting the three areas where MLC really can provide value to, the biomanufacturing industry is really kind of having a broad portfolio of products to offer that's really tailor-made to or tailor-fit to the end application and use. Having expert services to really help that selection and that scale up, whether that's, technical support or temporary equipment, all the way to manufacturing scale and having that bolt-on slurry system that really becomes kind of an easy button for using the products. Oh, and with that, I will open it up for questions.
Great. Thank you, Corey and Michaela, for sharing more about MLC's calcium hydroxide products, services, and systems, including the CalFlow system. I really appreciate that you talked about how this is really about matching products to process and executing on supporting these bioindustrial manufacturing processes. So please, attendees, feel free to either type in your question in the Q&A, raise your hand, and I have one question first that I want to ask, and Corey or Michaela, I welcome either of you to respond. So, what are the most common mistakes you see when teams first switch from sodium hydroxide to calcium hydroxide?
So I think kind of what you end up with in that case is there's just some fundamental differences in the handling and movement of the material. So sodium, obviously, it's pretty much soluble with any other counter ion it comes into touch with. So whenever you're running a system, your byproducts are going to be quite a bit different. And then also the solubility of the material itself as you're pumping and moving the material, it's completely solution-based material. And so the way you design your system is a little bit different than what you would do for something that is a slurry, kind of like the calcium hydroxide, because there you have a few other tweaks you want to do. You want to make sure your system is specifically designed to handle those slurries. And that's kind of where, the CalFlow system, and I'll probably open the floor up for Hugh to kind of give a little bit of insight into this from his experiences as well. But understanding exactly what those small tweaks are that takes you from a good to great performance, being able to understand the differences between that full solution versus the slurried solution comes into play. Hugh, do you want to add anything to the response? You're muted, by the way.
You're on mute, Hugh.
I got you. I'm on now. Basically, when you talk about the change, the whole goal of the CalFlow system is to make it, even though it's a suspension, to make it as easy to feed as you were doing a solution. And 100% agree with you that there may be some variations, but the bottom line is if you can deliver it constantly, then that's the ticket for smooth operation.
Great, thank you. Second question from the audience. What kind of scaling challenges can be expected with calcium hydroxide versus other chemistries?
So that kind of goes back to just the general solubility difference of calcium versus some of the other ones. So, with sodium, you're going to end up with mostly soluble byproducts, or if you reach certain critical points, you can start to crystallize, but generally you're reaching soluble byproducts. With calcium, it likes to form precipitates, which may be advantageous for you. If you're trying to remove solids through centrifugation or get rid of materials or separate it, it provides a nice handle. But at the same time, it can cause potential buildups. And so there are simple things you can do to mitigate that kind of thing. So one thing is control the percent solids. There's actually some counterintuitive kind of aspects to how you do that ultimately can actually give you really good performance and really reduce any sort of scaling style challenges. And then the other thing they're just simple things like flush out procedures, washing down the sides. They're just simple, practical things that can really mitigate that to not make that much of an issue. So that's kind of the big thing you see is just that potential for precipitation, which pros and cons.
Corey, if I can mention too, on pilot testing, small scale, you may be using a much thinner or lower percentage slurry while doing the testing and piloting, and then when it's upscaled, the full scale would use a higher percentage product.
All right, thank you. I have another question from the audience. How does handling differ at the bench scale versus the pilot scale versus larger scales, so commercial scale?
I think you kind of started in on that one already, so I'm going to let you keep rolling.
Now, I just probably more of my work is on the pilot side anyway, and so in most of the tests that I run, I'm going to be running a 1%, 2% stock solution, and then after the testing is done, and if it goes up to, like Corey was saying, 10,000 liters or something like that, then you'll increase the concentration of the calcium hydroxide to match the dosing pump that you have. So, yeah, you kind of play with the suspension strength to make it work best.
Great. I have a very relevant question about supply chain. So is liquid calcium hydroxide more or less likely to run into supply chain issues than other options?
So
So
generally speaking, go ahead, Mikhail.
I can take that one. So I think, the good thing, or kind of what's insulated a little bit with calcium products, is they are majority produced domestically. So you do not have the challenges with kind of import tariffs and those types of things. It is, calcium products, they're not all created equal, that's for sure, but it is one of the most, abundant, minerals on Earth, actually. So it is something that's widely available. And so typically, unless we're talking about transportation, that's where, things can get tricky. But as far as availability and domestic supply, that's really where calcium products tend to shine.
Thank you. I have another question here. How should operators think about slurry handling and feed system design? And what separates a system that runs reliably for year after year versus one that has constant issues and constant need for, process improvement or engineers to visit the site?
Consult a Lyme expert, a calcium expert
Okay.
first.
So this is kind of my wheelhouse.
Yeah.
Basically, what we offer, and we've been doing this for 4 decades, is it's pieces of a puzzle. Okay. If you have an engineered system and you're missing one piece, then you may have clogged lines, or you may have sediment buildup in the tank, or different things that happen because of something structurally that's not in the design. So what we offer to the customer is a guarantee that if they use the CalFlow system and a slurry that meets our spec, then we will tell the customer there will not be any sediment buildup in that tank for the life of the system, and there'll be no clogged feed lines. So you're handling particles, and if you keep them moving, then the design is going to work. But there are some minor things that can be left out and cause major problems at the end of the day.
Elbows, kind of hard corners.
Yes,
yes. But that's why kind of offering the expert services is really part of our wheelhouse, because we know how to handle calcium products. And so we want to make sure that at the onset, those are engineered out, those trip ups.
And I would say too, we're particular in that a lot of times we get asked to make a modification that's not in line with what we do. And we just want to don't want to change something that's been working so well so long,
Great. I have another question from the audience. So are there any insights or findings that you've understood from the industry voice of customer work that you've been doing that you'd be interested in sharing? So I know you shared some of that on the slides, but anything that you want to highlight?
Sounds like a follow-up conversation. Feel free to reach out, and we can talk more about what we've learned.
Great. Well, any other remaining questions from the audience, feel free to type those in the chat. As I mentioned at the start of the webinar, MLC is a BioMade member, so you can find Corey, Michaela's, and Hugh's information both in the member directory. We will also be uploading the recording of today's webinar and the slides to our member portal, so that you can share those with colleagues or watch those at a later date. I want to thank MLC again for their partnership in BioMade and for hosting this webinar today, and really helping our member ecosystem understand that there are different ways to adjust pH and new uses for lime and calcium hydroxide for fermentation.
Thank you so much.
Thank you very much.